Okay, hi everyone. So, attempt 2, this is the last set of videos that didn't have audio on it before that have had to be redone. So, I'll try again and to muster as much enthusiasm for this up as I can. Uh, by the way, what you missed before was really, really good. You know, there were flying monkeys in it and everything, but fortunately they couldn't come for the second try. So, what we had in the first video then was the recurrence relation. So let's just remind ourselves of what three things we're looking at here. So C2 was a geometric series, and we are going to look at that later. And that's where you have your term numbers on the top. So 1, 2, 3, 4, all the way up here. And every time something was being multiplied, or yeah, multiplied by something, there was a common, what's called a common ratio. So a common ratio, everything here you can see is being times by 2. So moving from terms is being multiplied by something. So that's geometric. So geometric multiply. What we've done just before this was the recurrence relation. So this is C1, okay? And that's when you have something which is based on the next term is informed by the previous term. So it looks something like that, where you've got either UNs or UKs. If you had, say, UN plus 2 is 5 UN plus 1 plus 3 over 2. Again, that's a recurrence relation because the new term is based on the old term. Number 2 then was arithmetic series. And this is also C1. And this is the last topic to be covered in C1 before you can now go ahead. Oh, apart from integration, actually, sorry, there's integration as well. Before you can start doing all your past papers for C1. So arithmetic series, that's what we're covering now, and that's where each term has something added to it. So let's say, or subtracted to it. So let's say we've got 2, minus 1, minus 4. Okay, for the first three terms, this is where we're going to start. So U1 is the first term, isn't it? That's the way of notating the first term, so that's 2. U3 means the third term, so that's minus 4. So this is what the U notation means, okay? But what we're interested in is finding general rules for things. So forget everything you learned in GCSE. Once again, you've been lied to. We're not going to do all that T stuff or whatever you did to find the nth term. We're going to find it using algebra in a general case. So what do we mean by the nth term? I mean, if I gave you, if I said, what's the 100th term? What's the 1000th term? What's the millionth term? You'd be able to tell me very quickly using a formula. So how do we derive the nth term? Well, we're going to do it in general then. So 1, 2, 3, and you're always going to use this structure. And we're going to have the nth term on the end, n minus 1th term, n minus 2th term. So in a minute we're going to do another proof, which is the sum of the series here, and it's going to follow the same procedure. So we'll always do 3 on the left, 3 on the right. So term 1, the first term is always called A. So A is always first term. And every time we are adding a common difference to this thing. So D is called the common difference because it's arithmetic. We're either adding or subtracting this value, whatever D is. So every time we're adding D. So the second term is going to be A plus D, isn't it? The third term is going to be A plus 2D. So A plus 2 lots of D. Because every time we're adding D, aren't we? Adding D, until eventually we get to the nth term. So you can see what's going to happen. This has no D, this one has 1D, this has 2D. So can you see that for the nth term, it's going to be A plus n minus 1 times D? Yeah? Because if it was the fifth term, it would be A plus 4D. So our nth term, UN, our formula for that is A plus n minus 1 D, because you can see that D is being added n minus 1 times, so the term number minus 1 times to A. So this is our nth term formula for arithmetic, and you must remember this, okay? More interesting though is deriving the sum of the series. So the sum of the series here. And again, that comes from a very specific proof. So at the moment we don't have a series. This arithmetic thing is not a series because we're not adding all the terms up. But the sum of the series, a series is a sum of all the numbers within the sequence. So we are doing a series now. So how do we prove? And I'll give you the formula now. The formula is n over 2 times 2a plus n minus 1 lots of d. How do we get this formula? Well, that's where the proof comes in, and you must know the proof. You have to know it. And in your exam it will say prove the sum of series formula. So this is how you do it. So this is how you do the proof. And what's famous about it is that Gauss, you may have heard of Gauss, a famous mathematician, as a really young kid, let's say 12 or something I think, his teacher asked him to add up all the numbers from 1 to 100 together because he just wanted to give them something useless to do to occupy their time, stop them messing around. And he just came up with this formula within, say, 10 minutes. And the teacher couldn't believe it. The first stroke of genius. So let's see if we can be as good as Gauss. So term 1, term 2, term 3, dot, 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 n minus 1, n minus 2. So always 3 from the front, 3 from the back. And this is exactly how we'll do the proof for the geometric series. So term 1 was A, term 2 was A plus D, term 2 A plus 2D, dot dot dot, and the last term was A plus n minus 1D, and now we can work backwards. So this is A plus n minus 2D, A plus n minus 3D. Now remember, we're trying to find the sum of the series, Sn. So that means we've got to plus everything together now. Yeah? That's what the sum of the series means. So how do we get this whole thing to look like this? Well, what Gauss did was a very ingenious trick. What he did was he wrote all of the terms in that first line back to front. So he now just switched the order around. So he put the nth term with the first term, and then the n minus 1 term with the second, and so on. So n minus 3d with this one, dot dot dot, and then the nth term he put with the first. So here we've got a plus d, and here we got a plus 2d. 2d. Okay, and then what he did was he added it all up. So big add to the left. So that gives me Sn plus Sn, so that's 2 lots of Sn, yeah? And now let's think about it. So we've got A plus n minus 1d. So that's 2a plus n minus 1d. Hopefully you can see where this is going now. A plus nd minus d. So hopefully you can see that this is 2a plus n minus 1d again. Because you can see if we multiply this out, nd minus d plus d. Oh, sorry, I've read that wrong, haven't I? It's not a 1, it's a 2. This board is a bit crap to write on it. So a plus n minus 2d. Let's do that again. So first term plus the last term, 2a plus n minus 1d. This term plus this term, 2a again, plus, and it will be n minus 1d, and the reason why is because if we multiply this, nd, multiply that, minus 2d, then plus that d over here, we do get nd minus d, which is n minus 1 times d. Yeah? So that's where that comes from. And then if we add this one and this one, we get exactly the same. 2a plus n minus 1d, dot, 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 dot. And then you can see here that you're going to get exactly the same if you go from the back. So how many times does this happen? This happens n lots of times, doesn't it? Because there are 1, 2, 3, all the way up to n terms. So we're saying 2Sn is n lots of 2a plus n minus 1d. So for the actual proof, I would do dot 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 like this, and there are n lots of them, and you could do from the back as well. So you could say 2a plus n minus 1d. That's this one, and then this one again, 2a plus n minus 1d to keep it symmetrical, and then 2a plus n minus 1d again. It's a bit cramped because the board space is a bit cramped. And then finally we can divide by 2. Can you see? And we get the formula that we want. Perfect. There is another formula as well that means exactly the same thing. If you think about it, this is Sn is n over 2, 2a is a plus a, isn't it? A plus a is 2a. You still got the plus n minus 1d. So can you see this is n over 2 a plus L, where L is the last term. So that's lowercase l. Don't get it confused with the recurrence relation L. So, right, I could have done it on this slide, which had a lot more space. Okay, know that for next time. You guys can do your one on that one there then, if you haven't done it already. But we'll do it in class, so you will have to know the series one by in your. You will have to know it off by heart. Okay, so let's look at this question here. So I'll write down my formulas. It's always good to write down the formulas. So the nth term is a plus n minus 1d. We know that the sum of the series is 2a plus n minus 1d, all times by n over 2. And we just said that that is exactly the same thing, n over 2, a plus the last term, where L is the last term. Okay, so question says, find the least value of n for which sigma 4r minus 3 is greater than 2000, where r goes between 1 and n. So we know what this sigma means now, and it tells us that r is going between 1 and n, or 4r minus 3. So let's first work out what that is. So this is 2000 here. So let's work out what this sum is. We know that this means moving from r, from 1 to n, up in terms of integers. So when r is 1, this is 4 times 1 minus 3 is 1. Plus, because at the moment we don't know if this is an arithmetic series or not. If r was 2, 4 times 2 is 8 minus 3 is 5. If r is 3, 4 times 3 is 12 minus 3 is 9. If r was 4, 4 times 4 minus 3 is 13. So this would go all the way up to n. So when is this sum bigger than 2000? Because remember, it's the sum Sn here. That's what it's referring to. Is it an arithmetic series? Yes. We know that the first term is a, so a is 1. And we can see the common difference must be 4, so d must be 4. So we can go straight into Sn, which is n over 2. 2a is 2 times 1 then, plus n minus 1, lots of d, which is 4. And it's asking, when is this thing bigger than 2000? So we can multiply out this bracket. 2 times n is just n. 2 times n over 2 is just n. And then n over 2 times this thing, so plus n over 2 times 4, which is 2n, n minus 1. Remember, if you're not sure how I'm manipulating this stuff, just stop the video and make sure it makes sense to you. So I've multiplied it all out, and now I'm going to make everything look like a quadratic, right? So 2n squared, n minus 2n is minus n. Bring the 2000 over, is greater than 0. Could factorize this. Remember, it's an inequality, so I must have some kind of graph. It's a positive quadratic, so I could try and factorize it, or I could use my magic calculator, so the equation solve, because it looks like a bit, you know, don't really like numbers very much. Right, so we get 31.87 at the moment, so 31.87, and we get minus 31.37. So I can see from my inequalities graph, when is it bigger than 0? Well, it's here. So this is positive, and it's here, isn't it? Using that arrow technique for inequalities. So we're saying n must be bigger than 31.87, or n must be less than minus 31.37. But n has to be positive, doesn't it? N has to be positive, and it has to be an integer. Therefore, n must be 32 for that to happen. And you can test that by whacking 32 back into your series here. Does it equal more than 2000? Let's just quickly try it. So if we get n is, so 32 is your answer, so use that as your answer button. So answer divided by 2, all times by 2 plus answer take 1 times by 4. And we get 2016. And if you whacked in 31 to check it, so I would always check the number before just to make sure I got the inequality right. If I whack in 31, 2 plus answer minus 1 times by 4, and you get 1891. So we're happy. Okay, next one. This time we have the sum of the first two terms of an arithmetic series is 47. The 30th term is 62. So I would never just write u30 is minus 62. That's a complete waste of time. That's not going to tell you anything. You know that un is a plus n minus 1d, so, and we know we're going to have to use that. So let's do it. So u30 is a plus 30 subtract 1, so 29d. And we know that's minus 62. Much more helpful, because it's prompted me to basically do a simultaneous equation. I need to know what a and d are, right? So it also tells me that the sum of the series, so the sum of the series is n over 2a plus 2a, sorry, n minus 1d. So quoted the formula, it says the first sum of the first two is 47. So S2 is 2 over 2, 2 lots of a plus n minus 1, and n is 2. So that's just plus d equals 47. 2 over 2 is 1, so I got 2a plus d is 47. I already know that a plus 29d is minus 62. So you can choose here to do, just your regular GCSE elimination if you want. So therefore, if I times that bottom one by 2, I get 2a plus 58d equals minus 124. So this is equation 2, equation 1, which we can now solve. So if we subtract them from each other, I get 57d is minus 124 minus minus 62. So that's going to be minus 62. So I just realized I've subtracted the wrong thing. So I should say 1 subtract 2. Yeah. So I'm actually doing, actually I did 2 subtract 1. Ugh. So 2 subtract 1, it's been a long day. Okay, minus 124 minus 47 is minus 71, so 171. Divide that by 57 and you get d is minus 3. If you know d is minus 3, then we know what a is. And we can shove that back into, say, here, yeah? So 2a minus 3 is 47, so therefore 2a is 50, and therefore a is 25. And again, you could test that. So we could test whether that's the case by testing it, by trying that out. So does U30 indeed equal minus 62 as we thought it was? Well, A is 25, D is minus 3, so plus 29 times minus 3. Do we get minus 62? 29 times minus 3 plus 25. Yes, we do get minus 62. So it should work. The question actually asks us though to find the sum of the first 60. So I want S of 60, which is n over 2. So 60 over 2 times 2 lots of A. So 2 lots of 25 plus n minus 1. So that's 59 lots of D, which is minus 3. Now remember in your exam, you are going to have to do long multiplication. I don't know how much help you need with that. And this should be minus 3810, I think. So just check in case I've made any mistakes. If you think I've made any mistakes, then just email me and let me know. Yeah. So yeah, in C1 you are going to have to do. Are going to have to deal with these horrible numbers. Okay, you can't use your calculator to bail you out, unfortunately. I think they're doing away with that in the new A level, but you guys have to put up with it. So that's it for arithmetic series.